This is problem number 25 from the summer assignment, and it's traditionally one that's given students some trouble. I think the reason that it's tricky is that your goal is to solve for y, but y is hanging out in two different spots. The other thing that's tricky about it is that it deals with fractions. And so the first thing I'm going to suggest is that we write the left side of the equation as a fraction. And the next thing I'm going to suggest is that we get rid of the fractions in general. And you do that by taking both sides of the equation and multiplying by 7 minus 6y. So that these two terms cancel to 1. And what we're left with on the other side is x times 7 minus 6y is equal to 3y minus 8. And then we need to get the y out of the parentheses, so we're going to distribute. That's going to give us 7 times the x minus 6xy is equal to 3y minus 8. And then, since we want to solve for the y, we better get y's on the same side of the equation. So what we're going to do is I'm going to add 6xy to both sides. And then on this side, now every term, this one, and this one, is going to have y, except for the last one, the 8. So let's move that 8 away by adding 8 to both sides. When we do that, we end up with 7x plus 8 is equal to 3y plus 6xy. Well, now we're almost there. All we need to do is get that y in one place. And we can do that because if you just look at the right side of the equation, see that there are two terms, and we can factor a y out. So if we take y out of the first term, we're left with a 3. If we take y out of the second term, we're left with a 6x. Nothing has changed on the other side of the equation. Last step is to take this 3 plus 6x and divide it from both sides. And so what we end up with is y is equal to 7x plus 8 divided by 3 plus 6x. And that's your final answer.